Hi everyone, in this video we'll go through differentiation of parametric functions. So what are these parametric functions? So if you have two functions, right, like this, and both are expressed in terms of another variable, that is x is a function of theta, y is also a function of theta, and we need to find dy by dx, right? So in this case, such functions are called as parametric functions and we need to differentiate this, right? So what we do here is we'll differentiate this separately, right? We'll say dx by, differentiate with respect to what? Theta. So we'll differentiate this with respect to theta. This one also will differentiate with respect to theta, right? Say we get something here. Then we'll find dy by dx. How? Dy by dx would be dy by d theta by dx by d theta. That is, I'll take this one and divide by this one, right? So let's work this out. So dx by d theta is, a is a constant. What is derivative of cos theta? It is minus sine theta. Similarly here, a is a constant. What is derivative of sine theta? It is cos theta, right? Now we'll divide this a into cos theta, that is dy by d theta by dx by d theta. Here it is minus a sine theta. So a and a will get cancelled. We'll get minus cot theta. Cos by sine is cot theta. So this is dy by dx. So let's take another example. So here it is expressed in terms of t, right? So first I'll find dx by dt and here I'll find dy by dt. So a is a constant. Let's leave this. T minus 1 by t. What is derivative of t? T is 1, right? And what is derivative of 1 by t? It is minus 1 by t square. How do I say this? So d by dx of 1 by x is minus 1 by x square. Using the same formula, x to the power n, d by dx of x to the power is equal to n into x to the power n minus 1. Using this formula, now 1 by x I can write as x to the power minus 1. If I take x to the top, it will become x to the power minus 1. So instead of n we have minus 1. So minus 1 into x to the power minus 1, which is minus 1 into x to the power minus 2. I can write this as minus 1. I can bring this down. So I get the positive power, which is x square minus 1 by x square, right? Here we have t. So it is minus 1 by t square. So we'll simplify this. This is a 1 plus 1 by t square. This is dx by dt. Now similarly we'll find dy by dt. Y is this much, this one, right? So it will be a into derivative of t is 1. Derivative of 1 by t is minus 1 by t square, right? So I'll get a into 1 minus 1 by t square as dy by dt. Now I need to find dy by dx. So remember one thing, it's dy by dx. So first one should be related to dy, this one. So this should come in the numerator because this is dy and this is dx. So dy is a into 1 minus 1 by t square by this much, this one, a into 1 plus 1 by t square. A and a will get cancelled. So let me simplify this. Let me take the LCM. T square is the LCM, right? T square is the LCM. So I'll get t square minus 1. Similarly for denominator also I'll take t square as LCM. So I'll get t square 1, t square plus 1, right? Now again t square and t square will get cancelled. So I'll be left with t square minus 1 by t square plus 1. So this is dy by dx. Now let's take another problem. Differentiate tan square x with respect to cos square x. So this means this is one function, this is one function. So let me call it as u is equal to tan square x, v is equal to cos square x. I'm just naming these two functions. Now I have to differentiate this with respect to this. That means I have to differentiate tan square x with respect to cos square x, right? Which means I have to find du by dv, right? I have to differentiate this with respect to this. when this is with respect to cos square x, that means this should be in the denominator. This should be in the denominator. So it is du by dv. We need to find out. So let's first differentiate this separately, right? So now we'll have to differentiate with respect to x here, right, in this expression. So this will be du by dx. This is tan square x, which is nothing but tan x into tan x, right? So I'll have to apply product rule here. So I'll have to take tan x into derivative of tan x, which is secant square x, plus tan x, that is second term, into derivative of first term. Tan x into derivative of first term, which is again secant square x. So both of these are same, which means it is 2 tan x into secant square x. This is du by dx. Now similarly we'll find dv by dx. I have cos square x. So this will be dv by dx is equal to, I can write this as cos x into cos x, which is nothing but, I have to apply product rule. So cos x, first term into derivative second term is minus sin x, plus second term into derivative of first term, which is again minus sin x. So I'll get both of these are same. So it's nothing but 2 sin x into cos x. There is minus here, right? So it's minus 2 sin x cos x. Now the last step, we need to find du by dv. We need to find du by dv. That means the numerator should have u function, this one. So it's 2 tan x into secant square x by minus 2 sin x into cos x. 2 and 2 will get cancelled. Let me simplify this. Let me write tan x as sin x by cos x. Secant is 1 by cos x by sin x into cos x, and then there is minus here. This is nothing but sin x by cos square x by sin x into cos x. So I can assume that there is a 1 here. So there are two fractions here. So if I take this on top, it will become reciprocal. So it will become like this, sin x by cos square x into reciprocal of 1 by sin x into cos x. So this becomes a reciprocal. Now sin x and sin x will get cancelled. Here I missed the square here, right? So cos square x and cos x, this is cos cube here, which means I'll get 1 by cos to the power 4x. 1 by cos is secant. So minus secant to the 4 to the power 4x. So this is du by dv. Now let's take this example where two functions are given, right, x and y, with respect to t. Show that dy by dx is equal to minus tan t. So we'll take the first function, dx by dt is equal to, let's differentiate this with respect to t. Here we have to put product rule, right? We have to apply product rule. So first function is, this is first function, this is second function, right? So first function is e to the power t into derivative of second function. What is derivative of second function? Derivative of cos t plus sin t plus, now we'll take second function, cos t plus sin t into derivative of first function, that is e to the power t. E to the power t into derivative of cos t plus sin t is, derivative of cos t is minus sin t, derivative of sin t is cos t. Similarly, we'll just copy this, cos t plus sin t, derivative of e to the power t is e to the power t itself, right? Derivative of e to the power x is e to the power x. Actually e to the power t is common here, right? We need to take e to the power t is common. Sin t and sin t will get cancelled. So we'll get 2 cos t. This is dx by dt. Now similarly we'll find dy by dt. This is y function. Same thing, right? E to the power t, first function, into derivative of this one, derivative of cos t minus sin t plus second function, that is cos t minus sin t into derivative of first function, which is e to the power t. Now this is nothing but, what is the derivative of cos t minus sin t? It's sin t minus sin t minus cos t plus cos t minus sin t into derivative of e to the power t is e to the power t itself. Let's take e to the power t as common here. So we'll get minus sin t minus cos t plus cos t minus sin t. Cos t and cos t will get cancelled. So we'll get e to the power t into minus 2 sin t. Right? This is dy by dt. So now what is dy by dx? Right? We need to find dy by dx. So this by this by this. So it is e to the power t minus 2 sin t by e to the power t by this 2 cos t. This will get cancelled. So we'll get minus tan t. Sin by cos is tan. So this is what we are supposed to prove. The dy by dx is minus tan t. So with this, we've come to the end of this particular topic. If you've liked this video, do press a like and share it. Thank you.